Greetings. Welcome to the lecture number 5 of kinetic theory of gases. In our previous lecture, we have derived the Maxwell-Boltzmann law. We have find the molecular speed. Also, we found the values of the constant in Maxwell law. Mm, In that lecture, we'll find the average speed from Maxwell law, RMS, and most probable velocity. But in case if you forgot or you have no idea what Maxwell law is, or you cannot find their values of the constant, then it is recommended click the I button and go and watch and then start that video. Okay, let's start. In this part, we have to find the average speed from the Maxwell law. That average speed from the Maxwell law. Let's start with the define how we define that average speed. We can define the average speed in this manner: 0 to infinite v d nv by total number of molecules d nv. Now for a gas, the total number of molecule is capital N. We can write is in that form. So from 0 to infinite, so that is total molecule number of molecules. We can write that 0 to infinite v dnv. Now remember what we have learned in Maxwell law. These terms 1 by n is that terms. We are not doing anything with these terms. Now we have this, and for this term dnv we have a constant term 4 pi n a cube 0 to infinite v cube e to the power minus b v square dv. We have learned in Maxwell law, that is these terms. Okay, now we also learned in the Maxwell law how to derive this. Okay, this v cube is actually in Maxwell law it was v square, but here we have an extra v for d and v integration of that v. We have that v square, but here another v, so v square dot v is equal to, we have that v cube. If any problem, you can comment it. In our previous lecture, we got the value of a and that b. So now in this section, we are writing that value of a and b, that 4 pi, that n and n will be cut out. The value of a cube can be written in that form: m by 2 pi kb t 3 by 2, and the integration 0 to infinite v cube e to the power, we have that m v square by 2 kb t dv. Now this term is constant, so we have nothing to do with that, but there is an integration term. To find that expression, the average velocity, we need to solve that integration. Let's start. Now we need to solve that integration. If you want to solve it in yourself, just pause the lecture and try to solve it yourself. Okay, one hints for you: we have to keep it in a gamma function form. So let's start. To solve it, we need to let consider that this term as a x. Okay, x is equal to m v square by 2 kbt. We need to do this. Now if we have to find, let's find dx. What is the value of dx? The value of dx is equal to 2 mv by 2 kbt, basically mv by kbt. That is the value of dx. Now another thing we have to find, that the value of v square. The value of v square will be 2 kbt by m into x. This is the value of v square. Okay, now another thing we need to do, that the value of another thing that have will we have dv. Now v dv can be written in that form v dv. Okay, v dv can be written kb t by m t. Now rewrite that expression v cube e to the power minus mv square by 2kbt into dv. Rewrite that expression. Look what we have. We have that v square e to the power minus mv square by kbt into v dv. That v square into v, that means actually v cube. So we have this. Now we can now let we can put the value of v square and these all the terms in form of x. Let's rewrite this expression in terms of x. The v square can be written as 2 kbt by m x, that e to the power minus x, that v dv can be written as kb t by m dx. Okay, from this expression we can find that for x is equal to 0, v also 0, or for v tends to infinity, x also tends to infinity. So if we integrate this, the limit of the integration will be same. So let's integrate this term now. The terms, if we integrate, that will look like 0 to infinite. Look at this term 2 kbt by m, we have 2 times this, so we can 2 kbt by m square x e to the power minus x dx. Okay, now we have to solve that integration. Now look at this terms is a standard integration, but we can rewrite it in the gamma function form too, that 2 into kpt by m square, that is basically gamma 2, can be written as gamma 2. The value of gamma 2 is equal to 1, so the value of this will be 2 kbt by m square. So the expression average velocity can be written as 4 pi the a cube. So the value of a cube is equal to m by 2 pi kbt 3 by 2 into this term 2 kbt by m square. That terms, if we simplify this, we can get that 8 kbt by pi m. This is the average velocity, average molecular velocity from we get from the Maxwell law. After getting the average speed, let's find the root mean square speed. We can write this as r m s. We can write this as this. Okay, in the way of finding the constant in molecular speed, to find the value of b, we get an expression that is this is equal to 3 by 2b, that can be written as 3 by kbt by m. Okay, now for root mean square, we can v r m s, we can write that 3 kbt by m. This is the root mean square. If anyone has any doubt how we get this, you can read through our how to find that value of the a b and the value of the a. You will get that point. Okay, now let's go to the next. To find the most probable molecular speed, let's understand what is the most probable speed first. We have plotted a curve that from v versus that f is equal to dnv by dv, that maxwell distribution function curve, this versus this, and this is going to look like the curve look like that. We have to find for at a point of where we find that this function maximum. Okay, we can understand it in two ways. One, what we have learned in our childhood, how to find the value of maximum value of a function, that we need two derivatives and the derivative will be 0, for which value this derivative will be 0 is that value will be the maximum. Maximum, so says that this is the most probable velocity. The most probable velocity is defined as that velocity for what, and the this function distribution function will be maximum, is called most probable velocity. Now on another way to understand this, when it was at the highest peak, then there will be no the slope will be 0, slope will be 0, otherwise, so that slope will be 0, so the df dv will be 0. So the concept of finding most probable molecular speed is this. Now let's try to mathematically find it. Okay, the value of f we got from the maxwell law is 4 pi n a cube e to the power minus b v square. This is that can be written as 4 pi n, value of a cube can be written as m by 2 pi kb t to the power 3 by 2 e to the power mv square by 2 kb t v square, here also v square. That is the value we get from of this, we get from the maxwell law. Now we need to derive that df by dv, so we have to differentiate this function with respect to dv. Let's rewrite this and differentiate it. We have to find the derivative of these terms. uh, so look at these terms, this is a constant term, so that will be not useful to us for derivative. 4 pi n, we can write this term also outside of the derivative, 2 pi k b t 3 by 2. Now we have to find the derivative of these terms only, dv v square e to the power m v square by 2 kb t. Okay, we can write this in that manner, 4 pi n m by 2 pi kb t 3 by 2. Now look at that expression, we have to derive. Once we will derivation find the derivation of this and it will be same, and plus the derivation of these terms and that will be same, so that write 2b e to the power this term mb square by 2 kb t minus now keep that term same, v square. Okay, these terms will be minus of 2 m v square by 2 kb t e to the power minus m v square by kb t. Okay, we got this total derivation. Now look at that. We can now that expression can be write in the form of pi n m by again 2 pi kb t by 3 by 2, and this expression can be write in the form of 2 minus m by kb t. Okay, that expression can be written as v square into v e to the power mv square by 2k t. Okay, that expression, if you don't understand how we get this from this, just we take common this term v to the power mv square by kt. So we get this term, right? Now look at these terms carefully. These terms have to be 0 to be finding the maximum velocity. Now for being the 0 of this term, either this term should be 0, and these terms only will be 0 if we have that velocity v is equal to 0, or otherwise this term have to be 0. 2 minus m by kb t v square have to be 0. Now look at the curve again. Now look at the curve again. For v is equal to 0, that means this point. We are not interested in this point, so we can give up. This sheet is no use of us, so we just will have to care of about another term we get for the value. Now for being this value of f 0, we need to have this term as a 0. To have this term as a 0, we need either this term will be 0, 2 by m k b t v square will be 0, or otherwise look at this term will be 0. If its term is 0, then v is equal to actually 0, then that will be 0. So v is equal to 0. Now look whether we will have to find these terms, or this term will be 0 to find to get this value 0. Now look at the curve again. For v is equal to 0, we are talking about this region, so we are not interested on that, so we can give up the that sheet, and we can use the another expression we got, and that expression is 2 minus 2 is equal to m of kb t v square. So this v square can implies that v square is equal to 2kb t by m. So we can write that v is equal to root over 2kb t by m. This v is actually most probable, this v is actually most probable velocity that can be write 2kb t by m. This point is actually root over 2 k v t by m, the root all. This is the most probable molecular speed. For your help, we have provided study materials in our description box. Thank you so much.